In this video, we will learn how to write an assembly language program to divide 16-bit by 8-bit number. So in this program, the first line of our program is dot model small. So small indicates that we have written all this data segment and the code segment within only one program segment. So we have to do the division of 16-bit by 8-bit number. So our first number is 16-bit number that we have declared with the help of this DW directive, and our number is ACH. And our second number is DB, that is number 2 DB0AH. So we require two numbers. The first number is 16-bit and the second number is 8-bit. And we have taken this number as AC and A. In that code segment, we are writing these two statements to initialize the values of our data segment in our code segment. Now we have to clear the values of AX, then values of BX and the values of DX to 00H, so that we have written the statement as move AX, 00H, move BX, 00H, and move DX, 00H. So whatever the previous contents are already stored in our AX, BX and DX register, that will be clear as a 0000H. So we are also writing here 00 and 00, and here is also 00 and 00. So our AX, then BX and DX becomes 0000H. Now we are writing here move AX, number 1 and move BL, number 2. So we are copying the contents of 16-bit reg number into our AX register. So here in this statement, we have to copy the contents of 16-bit number into our one of the 16-bit register. So that's why we have taken here move AX, number 1. So our contents of AX becomes 00ACH because we have taken this number 1 as 00ACH. So we are writing here 00 and ACH. So the first content will be override and it will store AL is equal to AC and AH is equal to 00. Now we have to copy the contents of number 2 into one of the 8-bit register. So we have taken here register that is BL and we have written the statement move BL, number 2. So after writing the statement, we are copying the contents of number 2 that is 08 in our BL register. So now here you can check that our value of AL is equal to ACH and our value of BL is equal to 0AH. So we can consider it as AX is equal to 00 is ACH and value of BX is equal to 000AH. Now we have to perform the division of this 16-bit by 8-bit number. So whenever I am writing here division BL, that time we have to check what are the contents of that source bit register. And here we are performing the division of that 16-bit by 8-bit number. That time we are storing the contents of quotient and the contents of remainder in our AX and DX register respectively. So here you can consider it as we are storing the contents of quotient in our AX register. So we can write it as AX divided by BL, and here we can write it as DX is equal to AX mod BL. But this will happen with that 16-bit by 16-bit number, because we have the two operations if the source is byte and if the source is word. But here you can check that our source is byte. It is not a word. If we have write here bx, then this second operation will be executed. So here in this program, this operation is not applicable. Here we can storing our quotient and remainder in our AL and AH register. So our AL is equal to AL divided by 8-bit unsigned source. So what is our source? BL. And now our AH is equal to, we can take it as AL divided by BL. But here we have to store the remainder so that we can write it as AL mod BL. So here you can check it as we are writing here AL, but our number is 16-bit number. That is A00ACH. So you can write it as AH colon AL divided by BL, and here you can write it as AH colon AL mod of BL. So this operation can be also written as quotient, that we are storing it into the AL register, is equal to AX divided by BL, and here you can write it as AH is equal to, that we are storing the remainder, that is AH is equal to AX mod of BL. So you can keep remember the 2 points whenever we are performing the division of this 8-bit number. Our source is byte, then we can store our quotient in our AL register, and we are storing the remainder in our AH register. So now we have to put the contents of that AX and BL register. So our AX is equal to 00AC divided by A, and here you can write it as 00AC mod of A. So now how we are performing the division operation? Here you can check that we can write it as AC divided by A. So after performing the division, we can say that A ones A. So A minus A is equal to 0. Here we can write C as it is, and if we are considering A is equal to 10 and C is equal to 12, so A and C, these are the hexadecimal number, and in decimal we can consider for A is equal to 10 and for C is equal to 12. And if we are dividing this 10 divided by 12 divided by 10, that time we can write it as 10 ones are 10. And we will get the remainder, that is 2, and we will get the quotient as 1. So we can also write it as A ones are A. And after writing this 0C minus 0A, we will get the value 2. So for 0C and 0A, we will get the value 02. So C can be considered it as 12 and A can be considered it as 10. So 12 minus 10 is equal to 02. So in this division operation, we will get our quotient as 11 and we will get our remainder as 2. So now we have to check that after performing the division operation, where the quotient and remainder will be stored. So in our AL register, we are storing the quotient. So in our AL register, the value is equal to 11. And in our AH register, we are storing the value of our remainder. So we are putting here value 02. So now you have to update the contents of our register. So now our AL is equal to, we will get the value that is 11 and our remainder is equal to AH, that is 02. Now we will check this output of this program in our emulator screen. But before that, you can check after division BL, we have written these two statements for terminating our program. So here, with the help of this 4CH interrupt, we are calling the DOS interrupt for termination of our program, and with the help of integer 21H, that is our software interrupt, we are terminating our program execution. This end dash is written for end of the segment, and this end will be written for end of the program. Now we will check the execution of our program in our emulator screen. The first of all, we are copying the contents of data segment in our AX register, so our X becomes 0710. Then we are copying the values of AX into our data segment, that is 0710, that we have copied it from AX register. Now we have already seen we have to clear these values of AX, BX and DX is equal to 00 and 00. So here you can check that these three values becomes 00 and 00. So now our AX becomes 00, BX becomes 0000 and DX is also 0000. Now we have to copy the contents of number 1 into our AX register. So you can check that our contents of AX becomes 00AC. Now we have to copy the contents of number 2 into our BL register. So check that our BL becomes 0008. That is, in BL consists of 0A. Now we are performing this division BL instruction. So in that division BL instruction, we are performing this AX divided by BL. And after that, your quotient will be stored in our AL register and our remainder will be stored in our AH register. So our quotient is 11 and our remainder is 02. Now we are calling this DOS interrupt, that is 4CH, and we are storing this value into our AH register, and with the help of this integer 21H interrupt, we are terminating our program execution. So here you have to remember these 2 points whenever you are performing the division operation with 16-bit by 8-bit number. That time our quotient will be stored in our AL register and our remainder will be stored in our AH register.